This is an example where we are looking at the relationship between greatest common factors of two numbers and then the greatest common factor of the Fibonacci values related to those values. So let's look at the first example here. It has been shown that if the greatest common factor of m and n is r, then the greatest common factor of f sub n and f sub n is f sub r. So let's break this down by looking at part A, where we look at m is 10 and n is 4. Let's find the GCF for those two numbers. So for 10 and 4, if we break these numbers down, 10 is divisible by 2, you get 2 times 5, and 4 can break down as 2 times 2. And that's as far as we can break down the factorization of those numbers. So the greatest common factor is they both have in common a 2. 2 is the largest number that will divide into 10 and 4. So this first statement up above says if the greatest common factor of m, so m is 10 and n is 4, equals r, so here my r is 2. Then it should be true that when I look at the Fibonacci sequence and I look at f sub m, f sub n, and I find the greatest common factor of those two numbers, then that should equal the position at f sub r. So let's go ahead and look at the Fibonacci numbers. So you can create your own list based on the pattern. I've also just gone to the internet and I've found there's multiple sites that list out a number, the list of Fibonacci numbers, and so this just is a nice way to look at the position and then find the number that's going to land there. So I want to do f sub 10. So f sub 10 is the 10th number in the Fibonacci sequence. It's 55. And then I want to find f sub 4. That's the 4th number in the Fibonacci sequence, and that is going to be 3. Now I need to calculate the greatest common factor for 55 and 3. Well, 55 is divisible by 5. It's 5 times 11, and 3 is just 1 times 3. They don't have any factors in common other than the number 1, so 3 is prime. So if you don't have any common factors, 1 is the GCF. So going back to this statement, if I find the greatest common factor for the Fibonacci numbers, it should equal f sub r. So f sub r, remember r was my GCF of the original numbers, it should equal the position at f sub 2. So now I want to look at f sub 2, and it's 1. And that is true. So the GCF of the Fibonacci numbers is 1, and that is equivalent to the number that I get when I go to the position where r is the GCF of the original two numbers. So you would select A, GCF of 10 and 4 is 2, and f sub 2 equals 1, which is the GCF of f sub 10 equals 55 and f sub 4 equals 3. Let's look at the second example. For m equals 12 and n equals 6, choose the correct statement below. And so we want to go through the same process. So m equals 12 and n equals 6. So if you think of numbers that go into 12 and 6, 12 is 1, 2, 3, 4, 6, and 12. Factors of 6 are 1, 2, 3, and 6. If you just list all the factors out, you can look at the greatest common factor for both is 6. So the GCF is 6. So that is my R value. Okay. So now I want to find f sub 12, f sub 6, and f sub r. So r was also 6. Okay, so looking at my list of Fibonacci numbers, if I go to the 12th position, it's 144. If I go to the 6th position, it's 8. Now we need to do the GCF of 144 and 8. So 144 is a little bit larger. It might be helpful to break it down by prime factorization, or you can say, well, find two factors that multiply to make 144 and then break those down. So 144 is 12 times 12. I can break down the 12 as 3 times 4. 3 is prime, so I'm going to circle that. 12 is again 3 times 4. Circle your prime number 3. Break down those 4s, and each of these give you two 2s, and now you've broken it down completely into the prime factorization. So it's 2 times 2 times 2 times 2, you get 4 2s, and then you get 2 3s. Okay, so 8, let's go ahead and do, if you do prime factorization for one number, you need to do it for the other number. 8 is 2 times 4, circle the 2, 4 is 2 times 2. So 8 breaks down as 3 2s. So then the GCF is the largest number of common factors they have. So if you compare the lists, they both have 3 2s in common. So 2 cubed equals 8. 8 would be the GCF for 144 and 8. So what this means is if I now look at f sub 6, which is f sub r, it should equal the GCF of the original numbers, which were 6 and 12. So again, if you look at your Fibonacci sequence, f sub 6 is 8. So yes, that is true, and we've verified that again. So you would select this first statement here that says the GCF of 12 and 6 is 6, and f sub 6 is 8, which is the GCF of f sub 12 equals 144, and f sub 6 is 8. If you look at the second statement, they have incorrect Fibonacci numbers here, so that's why that one would not be true. So you would do the same thing for part C, same idea there. And if you have any other questions, just let me know.